Right, so what we're going to do in this lesson, we're going to work through a couple of examples. Example number one, we will have there's question 5 in the 2017 national paper for November for grade 11. Okay, as you can see, it is made up of 4 questions. Number 1, state Newton's universal gravitational law in words. Number 2, explain the term weightlessness. Number 3, calculate the force between the Earth and satellite A. And number 4, what distance above the surface of the Earth should satellite B be to experience the same force towards the Earth as satellite A? Choose from greater than, less than, or equal to the distance above the Earth. Explain how you arrived at the answer. The answer for 5.1 is going to be on your screen as we speak. Now, this is a screen grab from the previous video. Each particle in the universe attracts every other particle with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the squared distance between their centers. Alright, so when we look at the question 5.2, it's asking me what is weightlessness. Weightlessness is the sensation experienced when all contact forces are removed. Okay, so just some explanation behind that is that when weightlessness is the feeling where all forces are removed, meaning all contact forces such as the forces of the ground on you, on the chair on you, on the airplane on you, and consequently the forces that you exert on those things as well. Now, therefore, weightlessness is quite often associated with being in space or whatnot. You can actually get a sense of weightlessness if you are just in an elevator that goes down too quickly, or you get a sensation of weightlessness when you are in an airplane where it goes down just a little bit quicker than what you're used to. Okay, so that is what we would consider weightless. Now, in 5.3, we are going to look at a calculation. In 5.3, we are being told that we are looking at the forces between the Earth and satellite A. What we know is that the mass of the satellite is going to be equal to 3,800 kilograms. Right. We know that the distance between satellite A and above the surface of the Earth is 25,000 kilometers. Now the radius is actually, or the distance between them is going to be the 25,000 kilometers plus something else, plus the radius of the Earth. So first and foremost, we have to convert that into meters. So it's going to be 25,000 times by 10 to the power of 3 plus 6,38 times 10 to the power of 6, which in the end is what we would need for our distance of the Earth. The mass of the Earth is always going to be given to you at the back of your exams. And the mass of the Earth is 5,98 times 10 to the power of 24. Alright, kilograms. These are in meters. Those are what you should be identifying right now. Those are the things that you should find from the question itself. Okay, so now we start with the equation. F is equal to G M1 M2 over R squared. G is 6,67 times 10 to the power of minus 11. Mass 1, 5,98 times 10 to the power of 24. And this is too small. Right, let me just do this properly. 6,67 times 10 to the power of 11 times by 5,98 times 10 to the power of 24 times by 3,800. Chuck those in brackets. All over 6,38 times 10 to the power of 6 plus 25,000 times 10 to the power of 3 squared. Alright, chuck that entire calculation into your calculator and we get 1,539.23 newtons. Okay, that is our answer for 5.3. Now, in 5.4 it says, what distance above the surface of the Earth should satellite B be to experience the same force towards satellite Earth as same force towards Earth as satellite A? Choose greater than, less than, or equal to the distance above the Earth. Explain how you arrived at the answer. Now, if you go back a little bit, you can then see, or I'll put on a screenshot of this, is that satellite B is a greater mass than satellite A. So if satellite B is a greater mass than satellite A, that means it can afford to be further from the Earth in order to experience the same amount of force. So your answer would be greater than. Okay, and obviously all of the explanation that I said, you get a mark. It's worth 4 marks. So you get a mark for it. The force would be the same because the mass is greater. So therefore, the mass being greater, the distance could be greater as well. And you could substitute these values into an equation to calculate, but you're not asked for that currently. Now, on to example number 2. Again, it's question 5, but this time it is from the Department of Basic Education's paper 1 of grade 11 in 2015. Okay, so the first question says, state Newton's law of universal gravitation in words. 5.2 says, mass of the sun is 330 times greater than that of the Earth. The distance between the centers of the sun and the Earth is 1.38, 10 times 10 to the power of 9 meters. Calculate the gravitational force that the sun exerts on the Earth. Then 5.3 says, how will the gravitational force that the Earth exerts on the sun compare to the answer to question 5.2? Write only, greater than, less than, or equal to. Give a reason for your answer. Now, 5.1, easy enough. It was a repeat of the previous question. Question of 5.2 though is one I wanted to have a look into. So you always start with your equation. F is equal to G m1 m2 over r squared. Now, G always the same, 6,67 times 10 to the power of minus 11. And the mass of the Earth is always going to be the same as well. 5.98 times 10 to the power of 24. But this time we have 330,000 times by 5.98 times 10 to the power of 20 minus 24. Because we have 330,000 times the mass of the Earth. Then the distance is 1.38 times 10 to the power of 9. And we square that. Chuck that all into a calculator. And we get 4.13 times 10 to the power of 26 newtons. Now, 5.3 asks us, what is the force that they will exert on the sun, or the Earth exerts on the sun, rather than the sun exerts on the Earth? Well, the force is the same. It is equal to. Why? Well, due to the fact of Newton's third law. If one object exerts a force on object B exerts the same force on object A. Alright. The only other times that they can complicate Newton's universal law of gravitation is with rearranging the equation. So you need to use your basic math to sort that out, as well as asking it about the surface of the Earth, where you have to actually add the radius of the Earth into it. Okay, well, if you would like to see more examples, just let me know in the comments. Yeah, have fun.